Hello, everyone. Now, I hope that today's lesson is shorter than usual because we have less to cover. Last week, our last problem is the integration of a function that is a mixture of exponential and trigonometric. And it turns out that in the end, we have to solve it like an equation. Now we have more examples like this. This again is an exponential and trigonometric. It's just I changed the angle to double angle. Anyway, you can see how I solve this problem. So first, ex dx is dex. Okay, so here we have dex, and that is uv minus v du. And then that is, this one will be cosine. It's 2 cosine 2x. Okay, and then I copy and take out 2. And then I have cosine 2x. And there is a change of right away. So in this step, I take out 2 and I did the integration by part. So dex and then ex. This one, I can use the by part formula again. So that is ex cosine 2x minus d cosine 2x. And that is cosine 2x. And that is negative 2 sine 2x dx. And then I have cosine 2x plus 2 e sine 2x. Now it looks like that I spent quite a lot of time sorting out the coefficients and the signs. And believe me, it's worth it. And then in the end, I'm going to open all the brackets. And I have cosine 2x. And this one is minus 4ex sine 2x. Like that. So in the end, by comparing the like terms, because I have this on the right and this on the left, they are the same term. They are the same term. So I have 5 this equals sine 2x e to the power x minus 2ex cosine 2x. So in the end, my answer is 1 over 5, maybe 1 over 5 e to the power x, and then sine 2x minus 2 cosine 2x. Close bracket plus c. You will get a hold of this. You will. I hope so. In the end, you solve it like an equation. I'll give you 1 minute to wrap it up. Okay. Now this question has a second solution. That is, instead of using ex dx equal dex, I'm going to integrate sine 2x dx. In this case, it's cosine 2x divided by -2. Isn't it? I think so, huh? I think so. Cosine, yeah. So that is this, and then let's go switch these two. So the first one is -1/2 ex and then cosine 2x. And this one is plus 1/2 e to the power x cosine 2x, like that. Now, of course, if you do that, you will create a fraction, and that's just you have to pay for that. And then with the second one, again, cosine 2x dx is d sine 2x divided by 2. And here I can use this again, you see? Huh? Sorry, there's a mistake. There's a mistake. I think it's close bracket here. Close bracket here. I don't know why it's there. Can you erase that? Yes, it's uv minus integration v du. So the close bracket is there, close bracket. And then this one, if I open the bracket, I will have -1/2 e to the power x cosine 2x. And this one, I have 1/4 e to the power x sine 2x. And this one, I have -1/4 sine 2x ex dx. And then by comparing both sides, I have this term and this term, and that is -1/2 e to the power x cosine 2x plus 1/4 e to the power x sine 2x. And then I'm supposed to multiply 4 divided by 5. So this one is multiply 4 divided by 5. This one is multiply 4 divided by 5. And I believe they are the same answer. Now, all I want to say is that for this type, again, the previous example and this example itself is a mixture of exponential and trigonometric. In that case, you can choose to integrate either part, either this one. This one is ex dx equal dex. And for this one, is sine 2x dx equal d cosine 2x divided by -2. If you use this, either one, it will work. But this is not the case with other questions, though. With other questions, you have to choose a specific one to do first, and then you can solve it. Now, some questions are similar like this. You have to do it twice or even 3 times, and then you go into a loop basically, and then you can solve it by comparison. I'll show you another example. This is my last example. This function is not a mixture, but it's like one inside the other one. This is log inside a trigonometric. It's cosine bracket. It's not cosine times, it's cosine of a log value. Cosine x, cosine bracket log x. And this one you can do the integration by part immediately, and that is u dv u dv equal uv minus v du. So this one is cosine bracket log x close bracket. Okay, and then I need to simplify. Now d cosine log x, that is sine log x, and then 1 over x. Now 1 over x here, now 1 over x is d log x. So that is a chain rule theirself, chain rule itself. So here it's simplified as x cosine log x plus sine log x, like that. And then that's x times cosine log x plus, and again, this method is used. Do you see? Again, this method is used. And then I will say this is equal to x times sine log x. And this one, you go back to cosine again. This one, you go back to cosine again. So that is, so this is cosine log x close bracket. Okay. And then by comparison, since you have this term and this term on the left and right, so that is 2 cosine integration cosine log x dx, that's x times cosine log x and x plus sine log x plus c. So in the end, it's x over 2. If I take out x, that's x over 2. You see what I mean? Now you can do the same practice. I gave you same, like two very similar exercise. Now you can practice. You need to work out the answer. You need to work out the answer. I think it's 3 exercise. Let me know when you're done. For the for the last question, there's an amendment. You pay attention here, it should be minus or here. We change the sign to minus. Okay, to save time, I think we should stop now, even if you haven't done yet. It's fine. The last question really is not very suitable for right now because you're new to this. I think it's more suitable if you have a little practice, maybe after a week. So you can come back to this question again later on. But I will explain. I will explain. For the first example, the first exercise, that is the textbook exercise. Now, because I provide the steps now, I think you must use cosine dx equal d sine x. And the second time you will use sine dx equal d negative cosine x. The two integration. Second time is sine dx d negative cosine x. And then in the end, you can find it by solving equation. Now, as long as your answer is correct, you can do it the other way. You can do it the other way. That's fine. The second exercise. Now, because I just showed you an exactly the same example, so I think you should be able to solve this one. Now, this one you would use the integration by part immediately. And then you will simplify this. That is d sine log is cosine log 1 over x dx. And then after simplification, you will do it again. And then this time it's d cosine is negative sine. Actually, it's negative. And then this way. To simplify. And then you can solve it by the final equation. The answer must be this. It's not like you can give me a different answer. Okay, for the last one, like I said, it really is difficult. Really is difficult, but you don't have to do it now. You can take a screenshot, maybe do it later. But I want to mention that in this question, the simplification of this one is a 3-layer chain rule, including this. That. So 3-layer chain rule is 2u du dx, and then in the u it's the cosine and then d log. So you can see 3 layers. It's a power. What is it called? The power function. It's the square one. It's a square, and then the trigonometry and the log. Inside log inside sine, and sine inside a square. So 3-layer chain rule. And then it's that this part, I want to point out that this part, the double angle formula is used. It's 2 sine A cosine A, it's sine 2A. The double angle is used. I know. I think without the guide, maybe it's not very good. Anyway, and then you use the integration by part again, and this time it's this minus. That's why I changed the sign. It's uv minus v du. Uv minus v du, and then you will do that, and then this time it's less, and then this one also it's cosine u du dx. You see, cosine u du dx. It's a chain rule, and then that. And then simplify. And then in the end, there is this. That is then a double angle formula used backwards. Here. Cosine 2a is 1 minus sine a squared. So change it back to sine, and the angle is halved. So there is the double angle formula, and then you double the angle, and then there is a double angle formula, you reduce the angle. So that makes up for everything, I hope. And then you can compare. This is the final answer. Again, you can practice this. You can practice this later. I don't think our exam will go to this extent. Okay. So that is the last part of integration by part. Now, why don't you download the new notes? You go here and download the new notes. Okay. What? Sorry. Wrong, huh? Please don't download. I will take it down. Sorry. I don't know why I gave you all. Sorry about that. It should be 34 to 35. I will upload again. Sorry. I just gave you a very large file. In fact, it's very small. It's just 2 pages, okay? Please don't print out 30 something pages. I don't know how. Please don't print out that. Now, this is the last part, the application of this integration. It's very straightforward. So 3 examples. So after this, we're done. 29. The slope at a point is given. The slope at a point is given. The slope is given. That means dy dx is given as a function. And it's also given that the curve passes through the point -9 and 1. Can you find the equation of the curve? That's very direct use. If you know the derivative, can you find the original or the primitive function? The original equal this. And then you just integrate. Right? Oh no. Square. Right? And then there is x squared plus 8 negative 1 over x. Let's see. Okay, that's not the end. That doesn't mean you found the curve. It's almost done. Now you must make sure that the curve passes through -9 and 1. So you will substitute -9 and 1 into y equal x squared minus 8 over x plus c. And that means 1 equal -9, -9. Huh? Sorry, I think I made the question wrong. It's 1 -9, not -9 and 1. Let's change the question. It's 1 -9. 1 minus. Okay. Oh, sorry. Is it negative? 1 and 9, negative 1 and 9. Otherwise, it cannot equal to this guy. No. Let's change it again. It's not 1, negative 9. 1, negative 9, no. It's negative 1, negative 9. Okay, negative 1. One moment. One moment. Let me check the original. Let me check it. It's negative 1, 9. Sorry. Is it negative 1, 9? Let me come back. Sorry. Let me change the number to negative 1, 9. I don't know why I changed. Negative 1, 9. Negative 1, 9. So this is 9. This is so C equals 0. Because I look at the answer, I don't know. Okay. And that means you have found the curve. Okay, but do not assume that C equals 0 or anything. There will be a point given to you. Next, part B. The equation of the tangent to the curve at the point where the curve cuts the x-axis. When y equals 0, x squared minus 8 over x equals 0. X cubed minus 8 equals 0. X equal 2. There is only one real root. So I found that where the curve cuts the x-axis. Therefore, the slope at x equal 2 is 2 times 2 cubed plus 8 divided by 2 squared. And that is 24 divided by 4, that's 6. Therefore, the equation is y equals 6x minus 2. That is y equals 6x minus 12. And then you're done. Okay, so very straightforward. Obviously, you need to use integration to find the original one. Because in the past, you used the original to find the derivative. Now I'm just doing backwards. And Poppy is the same application. It literally is the same application of differentiation. And you are using it. You're using it. Second example. Second example is that on the curve, the second derivative is given. And it's also given that the graph passes through 0, 2, and the slope of the curve at that point, that means 0, 2 is 2. From the equation of the curve. So for this one, I need to first find dy dx by integration. And this is not a very difficult integration. It's 4 e to x divided by 2 minus e to the power 2 negative x plus negative 1 plus c1. C1. That is 2e to x plus e negative x plus c1. That's my first, the first derivative. Now, how do I find c1? There is a condition, the slope of the curve at that point c is 2. So at 0, 2, dy dx equal 2 e0 plus e0 plus c1 equal 2. So I can find c1. Therefore, c1 equal negative 1. The second step is that y equal integrate 2e to x plus e to the power negative x minus 1 dx. Now integrate the first derivative, like the original equation, and that is equal to 2e to x divided by 2 plus e negative x divided by negative 1 minus x plus c2. And that will be e to the power 2x minus e to the power negative x minus x plus c2. Now, how do I find c2? I have another point that the curve passes through 0, 2. So substitute 0, 2 into y equal e to x minus e negative x minus x plus c2. We have 2 equal e0 minus e0 minus 0 plus c2. I hope that's correct. Or is it 12? It can't be 12, huh? C2 equal 2. Therefore, the curve should be y equal e 2x minus e negative x minus x plus 2, plus 2. There's no way to get 12. No. Now, if the second derivative is given, now you can do the integration twice to get the original. And along the way, you need to find the constants by substitution. Going on. Last one. This is a real life problem. It says that the figure shows an empty inverted cone of height 30 cm and base 10 cm squared. The water is poured into the cone at a rate of dV dt. It's like the rate of change. The rate of change is given. And V is the volume at time t after the water has begun to be poured into it. Find the volume of the water at in the cone at t equal 5. Okay. Have you ever thought about using the rate of change backwards? Yes. If dV dt is given, therefore, I can find V by integration dV dt at t with respect to t. So that is dV dt. Now I'm find V of t. V of t. And that is equal t squared plus 5t plus c. Okay, so I found Z, found like part of a little bit I found Z. Still, I need to find the constant. The constant you can find from the first sentence, empty inverted cone. So at first it's empty. So when t equals 0, v equals 0, therefore 0 equals 0 plus 0 plus c. Therefore c equals 0. And we can say that v equals t squared plus 5t. That is the function found. So when t equal 5, I think we can find v, that's 5 squared plus 5, that's 50. And then we can say the volume equal 50. The volume equal 50 cm cubed when t equal 5. It's quite obvious that you need to integrate. Part B. How long does it take for the cone to be filled with water of a depth of 18 cm squared? How long? How long? Now, the capacity of the cone, that is 1/3 times 10 times 30, that's 100 cm cubed. The capacity is the whole cone. And now the depth is 18. When the depth equal 18 cm, the volume equal 100 times 18 over 30 cubed. Now you can find the volume from the similar figure. So in this case, that is 3/5 cubed. So 3/5 cubed. $21.6. Okay, that's the volume. And then at what time? And then you can go back to find the time. So 21.6 equal 5, t squared minus 5, t squared plus 5t. And then t squared plus 5t minus 21.6 equals 0. You can find t. One answer is rejected, as one answer is negative. Is that fine? I hope this can give you some insight. The application really is very straightforward, and it's easy to be found. Technically, it doesn't have a lot of application because the definition of this integration is very simple, because it's defined as the reverse of differentiation. Then it's used to find the original function. Whenever you need to find the original function, that is what you need to do to integrate. I believe that's all. If you have any question, you can stay, otherwise you can leave. Have a good night.